Friends, Wi-Fi pros, conference goers, and even people watching this after the WLPC, lend me your ears. Today, I'm here to talk to you about how, in the OT world, I approach doing RF surveys and WLAN validation in what I call non-traditional environments. A little bit about me on the top right, that's my LinkedIn. I'm a consulting network engineer for a systems integrator called Prism Systems. I'm also the co-host of the Industrial Wi-Fi Shop podcast with Scott McNeil. Shout out to Scott. This is my wife. These two absolute units right here are my children. They're total Chads. This is my emotional support cat my daughter sent me with. And a quote from the book Dune that I like to live by is that survival is the ability to swim in strange water. And so I think it applies to all wireless engineers. I've heard some nightmare scenarios of systems that I wouldn't even want to touch. The attenuation of bodies in stadiums is kind of scary to me. So it's a quick list of some of the problems that we run into in some of our environments, especially in manufacturing and automation. Basically, it all boils down to limited access to where the RF is, where your client's going to travel. So kind of from a high level, these are the big bucket of 3 tools that I typically use when my Nomad or, God love it, my Proxim dongle and my air magnet machine or an Ekahau sidekick fail. The first one is I've been lucky enough to acquire WLANPi. Hamina has been gracious enough to allow remote connection with the Pi over Bluetooth. And then there's also the ability of the Siemens industrial clients to use an internal feature called Signal Recorder, which takes an active connection to a network, gives you a nice linear time series graph of some of the KPIs. It gets a little weirder sometimes in the unlicensed frequency. We do integrations with Fluid Mesh, and now it's Cisco CURWB. And so with that, you can't really use traditional survey tools, so we rely on the exported telemetry that they have inherent in them. And so kind of taking those toolboxes, taking those tools and thinking about it from a systems approach perspective, right? We have a goal in mind, and then we deploy those tools to help us make progress towards those goals. So we use the system to achieve our end goal. Now, a really good example that kind of encapsulates a lot of the problems that we see is something like this, an electrified monorail system. And so what this is, you know, it's a suspended rail, you got some high voltage electricity up there, and then you have an EMS carrier, which is the orange thing in the middle. And when you look at this, you'll see some machine fencing. It looks kind of hard for you to maybe want to walk in there. You can't walk in there during production. You can't go in there when it's powered on. It's got to be locked out. It's pretty dangerous. I'm standing here on the ground taking this picture. Actually, I'm not because it's from the web, but the client's way up at the top, so are my results going to be reliable? And so how do we accomplish this, right? If you look on the left, I've got the best Wi-Fi engineer that I could find for this example, and they've got an iPad to do their survey data. And so typically, what we would do is, since you can't be up at that client level, is we'd walk around the machine fencing, right? If you look on the picture on the right, there's kind of a little catwalk area, and then there's some red guardrails that are at the bottom. That's a drop-off. I'm not Wile E. Coyote. If I step off of that, it's going to be a bad day for everybody. Here's a couple more pictures. Sometimes you can get up in that catwalk and you can walk around near where the EMS carriers run up top. You can get pretty close to the client, but usually you have to have an escort, and I don't know how many times you've had to depend on a maintenance person, but a lot of times they're really busy. Same thing with the middle side. If you look kind of on the right, you can see the client and the antenna right there. So in the generalized example, probably the best example from this talk, I came to WLPC last year. I purchased an M4. I got in the Slack. Somebody said, hey, let's put some external antennas on that thing. So I drilled into my beautiful case. I put some external antennas on it. We had swapped to Hamina, and somewhere along the lines I discovered that you could use the WLANPi as a remote sensor. So bingo, we're connecting with Bluetooth. Now, here's just kind of an up-close view of it, right? You have to stage this vehicle in the maintenance bay. It's going to sit there. You get up on a ladder, you strap everything in, you seal it up, and once they deploy it, this thing's going to run until it cycles all the way around the assembly line. And you hope that you get it done in enough time that they don't stop production for the day, because then you got to add an extra day to finish out your track. So this has been kind of one of the closest things to like a traditional survey tool that I've been able to do to validate these networks, aside from the areas where you can walk in there. If you look on the left, you'll see it's all kind of buttoned up, ready to go. But this was, each of these loops represents basically 1 day of survey time. We did it as a continuous. Bluetooth connection, 50, 60 feet, no problem. I surveyed for 3 or 4 hours. The EMS carrier will pull into a station, especially when it comes through an elevation change, and it's going to drop down, and then people are going to start putting bolts on bumpers, tires, anything in that manufacturing process. So you got to kind of stand back, and even then, your antenna's pretty high up. Now, as you all know, we all are probably pretty familiar with NDAs. This is the coolest picture that I was allowed to take on this site. And then kind of the backup approach, or the second big bucket of tools that we'd use in these Siemens industrial clients, is the signal recorder feature. And so this is real easy. You log into the web page, navigate through a few menus, you configure the frequency with which you want it to report. You start your capture, you run it, you can log out of it, log back in, stop your capture, save the file. You get a CSV, you get a PDF print that's got all that CSV data appended to the end of it. In this example, this is a stacker crane, so it basically stores rolls of steel in a big long aisleway, big tall crane. And this is actually one link of a PRP link, so we had dual wireless links to this. And so I thought this was a good example because you can kind of see there's a little blue line at the top, so it's highly directional antennas. When it gets really close, we're going several hundred feet. We're over-modulating the radio, so we see incredibly high signal. And then if you look at kind of the second layer, you see the data rate kind of crap out in the middle where there's that big red band. And so, the retries increase, the data rate just drops out. And so that's actually like a penetration in that system where they feed the rolls in. And so we were able to uncover from an R-coax system and some other things there using this tool that there was interference, right? So this is a bonus slide. Come check back to it. But if you're doing like a remote connection to something, sometimes we're doing AP on a stick testing in entertainment or something like that, and you want to execute like an iPerf command and it's just you can use this no hang up command to execute a script to either do your server or your client portion of it. And then that way, if you do break connection, even if the SSH connection breaks, your command's still going to run in the background. I just thought that'd be pretty useful. So what's another way that we can deploy something like a Siemens client? Well, we surveyed this warehouse on the left, but we also want to know about automatic trailer loading. So we got an AP on a stick set up. We kind of on the bottom left, you can see we strap the client on there with the antenna. We're trying to get as close to the actual vehicle as we can. We get our forklift driver to run in there and run back out, and then we get to marry that along with our survey results. And so what that gives us is, we've got our standard tool, then we use this, and it helps us rectify the predictive portion of it and see, okay, how's it actually going to look? And not just for one trailer bay, right? We want to find out laterally how many trailer bays can one antenna go, and then that allows us to improve the quality of the predictive design that we deliver. Another example, if you look on the right, this is just a case that I built with a Manfrotto Magic Arm, which is actually pretty cool, and it's a trick I learned in the RFID world. But we had this strapped up 150 feet on a column, an overhead crane that just runs in one direction. We put a client on there on the other side, and the neat thing about the Siemens device is that you can use bi-directional recording, so you can get the AP view and the client view. And so you get as close as you can, you jog it all the way out, jog it all the way back, run it around for a while, watch it. You get some interesting results, but it gets weirder, right? We're still an unlicensed band, but now we're talking about non-802.11 RF systems, right? So it used to be fluid mesh, now it's the Cisco ultra reliable wireless backhaul. These are pretty cool. I'm really excited about some of the capabilities that these are going to now provide us. They're dual radio. They do a lot of cool stuff. So what if I want to go fast, right? I unfortunately have to go into the commercial side, so I'm in warehouses and stuff, but every once in a while I get to sneak over and do testing on a roller coaster. You build a test rig, right? We can't damage anything. We can't make anything permanent as a mounting on that vehicle, so we build something that can sit in the seat, let them strap it down, saran wrap it, put nets over it, and then we let it go. This is a multiple AP on a stick kind of test. We created a multiple AP environment, and then we have our clients running. All right, well, let's run a train. A couple of years ago, I got to do a project for a major subway system in the northeast of the United States, and we strung a whole bunch of fiber, put 16 APs in about 1.5 miles of tunnel, strapped our client radio onto the train, showed up, waited for the union guys to be ready to actually let us do our work, and then we let it rip. They were actually pretty good guys, so I'm not knocking on them too bad. But how's this possible, right? In the radios, you have to configure a telemetry packet. I'm probably going to say the wrong name up here because I'm nervous. There's a lot of you guys and gals. But basically, you configure the radio to export a telemetry packet that has all that same kind of information, RSSI, link error rate, all those kinds of things. And so the company I work for, there were already some internal tools that were developed through Fluid Mesh that carried over to Cisco, but we needed a little bit more. So this is the only kind of shameless shill thing. If you're deploying a CURWB system, Prism Stats Live, you can run it on an iPad or a Mac, but it allows you to do live view capture and parse some stuff. So I'm going to show you some slides for that. And also, I would like you to take a second, and I'd like you to look at your favorite 4-plus-year-old person in here and just let them know that they can use this. I don't know why it's that age group. This is an example of a PCAP that we took from that subway system. So this is just on the left, you're going to see our track map, and that's just column locations from the inside of it. But here you get packet error rate. You can slice the PCAP and look at a specific time series, but this is a linear plot of all of those metrics, right? And if you look, there's a blue line that kind of goes across the top. And what that is that's the envelope. So that's the active connection. That's not actually like changing APs. And then the multicolored lines that are in there, that shows you where you start detecting a radio. And then as you get closer to it, it improves. As you get further away from it, it decreases, obviously. The vertical lines represent handoffs. And then you can click on a packet. You can step through it slowly if you want. Another thing that you can do with these systems, if you're lucky enough to have outdoor and be able to get reliable GPS, this is a port job that we did, is you can actually use Apple Maps integration. You can import a CSV with your AP locations, and then you can step through packet by packet and see where that where that client radio is connecting, and then follow it along. So then you can see, okay, am I handing off between a bunch of radios? Maybe I don't have a good antenna position here. This is really useful for being able to visualize that. And then in a little bit more in-depth system, let's say some of our entertainment customers deploy this, but we have kind of a larger software package where it's incumbent on the person who's commissioning us to do this to provide us with a location packet from the vehicle, right? And so then we know where the vehicle is, and then we bitmap it or whatever the software guys do. I don't do that. But that gives us a location here, and then that allows us to marry the position with the link quality. So the green link is the active link. The dotted line is the next best thing that you can see. And this lets you kind of have like a scoreboard or like a longer historical view of everything that's in there. So that's kind of the bulk of the RF survey thing. And I just wanted to take a second in this because I'm kind of close on time and I want to finish beforehand. But this is Scott Krakauer. This was my mentor when I started at Prism Systems. I used to be a restaurant manager. I had no idea what a switch was, any of that kind of stuff. He took me under his wing. He taught me a ton of stuff. We lost him a couple of years ago, and there was a giant void for me personally growing as a professional. So I wanted to take this little bit of time, and I just wanted to tell you all, find your Scott. There's a lot of Scotts out here, right? Take a minute and let them know that you appreciate them. Let them know how much that they've meant to you, because once we walk out that door, we're not going to know what's going to happen, and you may not get another chance. I was lucky enough to talk to him a few weeks before he passed. But I know last year, you know, Keith, with your family coming in, it just kind of made me really realize like how much that it means for us to be able to be here with each other. It's meant a lot to me professionally. So, you know, here's kind of my high-level list of people that have helped me tremendously. So Keith, thank you so much for putting this together and giving us this opportunity. Devin Aiken, man, you know, drinking from a fire hose. Peter McKenzie, Mark, gracious with his time. Brian, I appreciate your forthrightness. David Coleman, excellent talk this week. Consuming your books has helped me learn a lot. Jerry's answered phone calls for me at random times when he didn't know who I was and was really gracious with his time. Jim seems kind of grumpy, but he's not really grumpy. Sometimes. Adrian, I appreciate being able to reach out to you. Your tool's been awesome. The WLANPi team, you guys have made my job so much easier. Keith Jones, my boss, gave me a shot. I had no business getting into a technology company. Fernay, my favorite Wi-Fi engineer with a Jim Palmer face. Thanks for keeping everything running for us. It's been an absolute pleasure. Again, my contact information is at the front of this. If you made a friend, if you haven't made a friend, I'll be your friend. Smell you later.